Okay, so for the first one, it says that, okay, 74. For the whole journey, distance traveled. Oh, so this will be 5 into 20. Oh, by the way, this is speed is in kilometers per hour and time is in minutes. So I think we should convert it into hours. So 20 divided by 60 plus this is 20 again and 40 multiplied by 20 divided by 60 plus this is, I don't know what this is, 52 to
Yes, sir.
74.
52.
74
Sir, why do you
minus
divide it by 60?
because this is in minutes, this is in hours. I want to convert it into hours.
Okay.
So this is, I think, I don't know. Around, I think 18. Should be 18 or 22. I don't know. 22. Okay, so 22 divided by 60 times, what is this? 6. Okay, now I add all of them.
Sir, first is 1.67, then 13.3, and the last one is 2.2. Answer is 17 kilometers.
17.2, right? 17.2 kilometers should be the answer. Right. Now you should basically convert it. It's very important. Now average speed. Average speed is the total distance over total time. That was, total time was 74. 74 divided by 60. So you use your calculator. Open the brackets. So it is 14. 14 kilometers per hour. If you have any questions, please let me know. This is why this was 3 marks, because it was a tough question. It's not an easy one. If you forget. State and explain which feature of distance time graph shows acceleration. Gradient. Gradient because speed, because acceleration is equal to change in velocity per unit time. All right, is it clear? State explain the acceleration of the person first 40 minutes. They're all flat lines, horizontal 0. Because all horizontal lines means 0 gradient. All right, question please. Okay, then going forward, the total mass of train passenger is this. The train is traveling at a speed of this. The driver applies brakes and the train 80 seconds. Calculate the impulse. So impulse is change in momentum. mv minus mv. Mass is 750,000. Final velocity was 42 minus 84. So this would be 315,000,000. Okay. Now it says calculate the average resultant force. To train. Okay. To train means now we have to take it positive. Divided by time was 80. The force is change in momentum over time. Okay. That is 3.93 or 4 times 10 raised to 5 newtons. This will be Newton second units. Okay, don't forget it. So that's how the shape of train helps it to travel at high speeds. If you look at it, it's like very aerodynamic, right? So we could write that it's aerodynamic. So it will reduce air resistance. Dynamic has other words like streamlined. Right. And okay, so if you see those big ships, right, that travel in water, they're also called liners or streamliners because they're like come from the same word. Okay, the train took 80 seconds to reduce speed. Explain why with the same braking force it takes the train takes more than 80 seconds to reduce to zero. Because now there will be less air resistance as well. First, air resistance also helps, right? But as the speed slows down, it does. On wet day, the train travels. Yes.
By the C part, we can write the lower to center of gravity.
Lower center of gravity? No.
Yes.
No. It has nothing to do with that. Center of gravity is more towards stability, and it's talking about going high speed.
Okay.
All right. On the wet day, greater distance before. Okay. The reason is that due to rain or due to wet surface of rail and wheels, friction is reduced. Now, a solar panel receives energy of 5 kilowatt. The thermal energy transferred solar panel with this. Cold water 15 kg enters and specific calculate temperature increase. Okay. First of all, we'll find how much energy do we have. Oh, what? Okay, there's time as well. Fine. So energy is power into time. So power was 5,000. Time was 1 hour. 60 minutes into 60 seconds. Okay, so this is going to be 1.80. 1, 2, 3, 4, 5, 6, 7 into 10 raised to 7 joules. Now it only converts like 20%. So now heat, the Q will be 20% of the energy transfer. Like this, I'm just explaining it to you. So 20% 0.2 times 1.8 times. That is 3.6 times 1, 2, 3, 6. This much energy. Now what you do? Q equals to mc delta theta. Q is 3.6 times 10 raised to 6. Mass is 15. Heat capacity is 4,200. And that's it. So we're going to do that. So we divide it by 15 and we divide it by 4,200. So delta theta will be 57 degrees. So that should be the change, my friends. All right, please let me know.
3.6.
Sorry?
How did you get 3.6? Into
It
10
says
to the 6?
this is the sun, this is the power from the sun. It only converts 20% of it. So we took like, this is the total energy delivered by sun. Only 20% goes to heat. So I calculated 20% of this, and that is the heat gained by water. Okay.
Okay.
Yes, Hadi. Now, state and explain one advantage and what is the advantage of heating water in solar panel compared to heater water in coal burner. One of the main advantages that it is renewable. Renewable and this explanation. Okay, renewable because it's sun is always there, I guess. Sun comes out daily, so it can be reused. Disadvantage is it is high cost, expensive to install, and it's expensive to install because the photo plates are not cheap to produce. You can also write other ones like it generates no pollution, it has low running cost, it has no emission of greenhouse gases and stuff like that.
Right?
Yes.
For disadvantage, I wrote it needs sunlight. Sunlight isn't present every time, right? That's why.
Not available at night. Okay, that's fine. And you could, yeah, sunlight is not present all the time. That's correct. Now, describe simple experiment to mark the position of fixed points in liquid and glass. So this is very important. So first of all, what you do is you place it in pure melting ice. Then what you do? You basically mark 0 degrees Celsius at mercury length. Okay. Then third, what you do? Place it in pure boiling water. Fourth point, mark 100 degrees at mercury length. Okay, that's pretty simple, right? Now, a scientist measuring temperatures at South Pole, these temperatures are minimum minus. State why liquid used in thermometer would not be suitable. Because mercury freezes at this temperature. Mercury is good for hot temperature, and for cold, alcohol is good. Right. All right. Now, state a design change that increases sensitivity. Sensitivity always increases by thinner bore or smaller bulb or liquid that expands more. Increases the range. Range means you should have longer tube length. State property of liquid ensures the linear scale is linear. So it should always expand uniformly. Anything that does not.
Sir, can you, are you free one day? I want to study about temperatures, thermometer
Yeah.
and temperature.
Yes. Why not? Uniformly. Okay. Over the weekend.
Sir,
Now,
could you increase the size of the bulb to make it more sensitive?
no. That's something, if you increase the size of the bulb, right? Like if you take more bulb, it would not get more sensitive. You know why?
Why?
Because the heat will reach slowly and it will be like, yeah, well, yeah, you could. Yeah, I think you could. That would increase the number. It will show you more change or less change. Yeah. No, I don't think so. You should use a smaller bulb in any case. Because if you do that, right, that means that it will be less like responsive and you know, as the mercury will reach, because there will be more mercury in it, I think. That's why.
All right.
But you can actually do what? You can actually make it like, yeah, more mercury with thinner. Yeah, but you can use a less, you know, something that expands less per unit change. Yeah, you could do that. Yeah, you could do something that expands more for sensitivity too. Something like that. All right.
All right.
Not be right. Okay, now who's texting me? Okay, now going to this one, it says draw 3 crests of the reflective wave. So whenever this question comes, you need to use a ruler. So you make a straight line first, like this, and then you have to make a normal line, and then you have to make exact like same. I'm doing it without, you know, me knowing the angle, but I've tried it to the same. So what you do then, you make wave fronts equal in length and perpendicular to the direction like this. You can also, you know, make like this if you want to. That's fine. All right. So 3 he needs, so you can make any 3. Let's see. And make an arrow like this, please. And say this is normal. These wavefronts should be 90° always. Now, the wave has a wavelength of this and this. V is equal to f lambda. Speed is 1.2. Frequency, and this is in centimeter. We need to change it. So 0.36 meters. So frequency will be 1.2 divided by 0.36. That would be 3.3 hertz. Okay, then it says complete the following sentences. An echo is the name for a reflected sound wave. Okay. The wave that forms an echo are type of longitudinal wave. Longitudinals are made up of compressions and rarefactions. All right. Then it says shows an arrangement. Right. Complete the path. So what you do? First of all, you would want to make a straight line like this. Then from this, go straight down 90°. And then from this, go to the eye. This should be exactly here. You can, I don't think so. He has asked anything else, but you can always draw normal lines. And it should be 45 degrees, 45 degrees, 45 degrees, 45 degrees. So you got to use your ruler. And then it says, show the refractive index with the critical angle of 45 is this. So refractive index with a critical angle of 45 is this. Okay, so sine C equals to 1 upon n. And we want to find critical angle, that is 1.1. Okay, we need to show this. Sorry, we need to show this. We can put 45. So sine 45 would be
Sir, shouldn't it be 1 over sine c? N equals to 1 over sine c.
yeah. So the answer will be 1.41 like this. See. All right. Now, then going to this one, A student makes a transformer that uses alternating current, electromotive force, blah, blah, blah. The student provided two lengths of insulated by U-shaped piece of iron shown. Complete the diagram, show the transformer, connect supply and output of the transformer. So what you can do is you can make some coils here connected with alternating current. By the way, the sign for alternating current is wave like this. Okay, and this will be your primary, and here
Sir, won't we make the secondary coil less with less number of turns?
it doesn't really matter. Has he said it? Oh yes, yes, you're right. So here you will be having more turns because we have greater EMF and we want to reduce it. That's fine. Then say explain the function of piece of iron in the transformer. Explain the function of piece of iron. Iron is basically something that causes increase the strength of magnetic field, right? So you can always write that it makes a stronger magnetic field in secondary. That's one use. Always do that. Now, the output of the transformer is connected to lamp. The current of lamp is this. Transformer is 100% efficient. So calculate the input current. Now, it's very easy. If you don't know how to do this, I'll tell you. Power is equal to VI, right? Since power is same, so V1 I1 will be equal to V2 I2. Now the voltage is 12 in the first step, that's 12, and the current is 100 milliamps. We want to reduce it to 2, and the current is I2. So this will be 12 divided by 100. Okay, sorry, 12 into 200 divided by 2. What did I do? So that is 600 milliamps. Like this. Any questions? Please let me know. All right.
The answer in the mark scheme is coming 0.017.
0.017 milliamp. Are you sure?
Ampere.
Okay, my bad. There has to be a lamp here. So this means that this is the output current. Sorry. Let's put it like I1 and 100 milliamps. So now what you do? 2 into this divided by 12. This is 17 milliamp. And
Yes, sir. That's
this will be 0.017 ampere. Is it correct now?
yes, sir.
All right. Another transformer is used to spool to step down main supply potential differences. The transformer is mounted in metal case. State and explain essential safety feature required for this. It should be earth. Metal case must be earthed. This is because that live wire can touch and conduct electricity through case. That's fine. All right.
Right? Can we not write double insulated?
Yes, you can double insulate it, but it says it has a metal case. They never said it's double insulated.
Okay.
All right, so usually once there is a metal case, you always have to write it like this. Okay. Then comes a light emitting diode, emits light when there is a current. Draw a diagram showing LED connected to, so it is lit in series with the battery and fixed resistor. Battery. And you should draw it like this, because display sign should always be where the current is coming from. Resistor. And like this, and it should be like this. Two arrows coming out.
So it's moved from positive to negative, right?
Yes.
Like
And the longer one is positive. This is negative. Okay. This is resistor. Okay. Then says LED. The LED is lit when it is 3.1 volts. Okay, let me change the color because I don't want to mix it up. So it says this is 3.1 volts. And the current in LED is 0.030 ampere. Calculate the value of resistance when LED is lit. I don't know what is the battery, right? Do you know what is the battery? That is not fair. The potential across LED is 3.1. And
3.1 divided by 0.030.
Resistance of LED. Sorry, I thought resistance of R. Wow, this is easy. 0.030 equals to R.
103.
103 ohms. Now, shows the power supply of EMF connected in series with lamp and heater. Okay, resistance of heater. So EMF is 12.5, and the potential across lamp is 2.1, and you want the resistance. So if this gets 2.1 out of 10.5, this will get 8.4.
8.4.
8.4 volts. If this gets 8.4 volts, do we have the current? Yes, we do. 1.5.
5.6.
Okay. It's 5.6. Oh.
Yes,
Okay.
sir.
Power is VI. Voltage is 8.4. Current is 1.5. And answer is
12.6.
12.6.
12.6 watt. Yay. And now this is super easy. This is for NAND. So for AND it would be 0, but now it will be 1. So everywhere there was 0 is 1. That's it. So easy. Now shows partially completed circuit. Okay. What do we need to do? Okay, reduce the name of logic gate Y. Where is Y? Acha. So when A and B is going, so we have to check D for it. When A, B was 0, 0, 1, 0, this is AND for sure.
And gate.
Yes. Complete the truth table. We want to find output E. What is okay?
Sir, above one is OR gate, below Y is AND gate. X is OR.
X is OR. How do you know? Because C is 1. Okay, that's OR. So this is OR, and this is OR. So when C is 0, this is 0, this is 0, 1, 0 is 1, 1, 1 is 1. That is 1, right?
Sir, I don't understand. How did you get E?
I got E.
How is X OR? Oh, X is same. Okay.
You told me it's OR. I don't know.
Yes, sir, it's correct. Okay.
It's X, right? X is OR.
Sir, I didn't see there were two X. I didn't see there were two X.
Right. उसने बताया होगा ना कहीं पे. Deduce the name of logic gate Y. So ठीक है. C and D. 0 and 0 is 0. 0, 1 is 1. 1, 1, 1 is 1. This is OR X, right? Now, the current in
Okay.
3 ampere copper wire, yes,
How do you know it's or?
because this
Sir, for check AB for C. 0 0 0 0 1 1 1 0 1 1 1 1.
so AB is 0 0, it gives C 0. When it is 0 1, it is 1. When it is 1 0 1, 1 1 1. So it means it is has to be OR. If this is X, this is also X, so this is also OR. Right? So we then start doing for all. Is
And
it
how
clear?
about why?
How did I get Y? When
Yeah.
it was 0 0, it showed 0 0 1 0 1 0 0. Only it was 1 when both were 1, and it is a property of AND.
Okay.
Yes. Now there is a current at 3. Calculate how many electrons pass through wires in 30s. First of all, we'll find charge. 300 3618. 180 coulombs. 1 electron is 1.6 times 10 raised to minus 19. So in 180 coulombs, how many? So it means that it will be 180 divided by, and the answer is, it means nobody has done it right, Hannah. Hannah?
1.125 times 10 raised to power 21.
1.125 times 10 raised to power 21. That is correct, my friend. Now, question number 10. The lead cylinder has a narrow central hole. State and explain the effect of lead. Absorbs radiation. Of what? Of gamma rays. Right? So that should be what it should do. Right? So, wait a second. Let me think. There's a radioactive source. There's lead. Okay, so it absorbs gamma in all other directions except one, which is this one, right? Now, describe the paths of alpha beta particle as they pass through the magnetic field. Now, this is something important. Please remember this.
I didn't
When the,
understand the first one.
if some will go like this, some will go like this, right?
Yes, sir.
So some will go like this, this. So it will absorb all the other ones except for the ones that go straight.
Okay.
Now, for alpha particles, they want us to explain the path. Now, alpha is a positive particle, as you know. So you have to use magnetic field is like this, right? So this is where your index finger should be. This is your middle finger here. So your thumb is out of the page. So it will deflect like out of the page. Is it clear? You have to use Fleming's left-hand rule, right? So we write according to Fleming's left
Sir, which finger represents the magnetic field?
index. Index down, middle like this. So your thumb will be out. It will deflect out of the page. That's what you got to write. Is it clear? For beta particles, because these are like opposite, right, in the chart, so they will deflect into the page, right? Opposite to alpha. Okay, do you guys understand what I'm saying? All right, then gamma rays, they will pass undeflected as they are uncharged. Is it clear, everybody? And that's it. Please let me know where you got stuck or something.